All right, so in 1.2, we're talking about variables and types of data. So in objective 3, we're just going to identify types of data. So basically, so fill in the blank vocabulary here. It just says simply a variable is a characteristic. Oh, I lied. Can't use this one. I have to use this. So this will be a characteristic. Bless you. Or a attribute, which is just a describing word. That can assume different values. Variables may be categorical, but we don't use the word categorical. You'll actually see the word qualitative. And we can kind of remember that qualitative is our categorical data because our root word is quality. All right. Or characteristics, as we saw beforehand. These are typically not going to be a number, but there are certain examples, and we'll see those later, where they can be numbers, right? And I'll explain that when we get to it. And then so they're called, again, qualitative variables, which again typically are not numbers. So again, a little extra there. Typically not numbers. Or they may be numerical, which is also called quantitative. So this will be quantitative. And the root word is quantity. Right? And that can simply just mean your numbers. So these are numbers. All right, so again, basically, like I'll do some examples now, but we'll see them again. Qualitative is like the hair color, could be ethnicity, it could be class, like what grade you're in. Those are going to be quality stuff because that's just the name of your area. Quantitative, being quantities, could be like the height of people, the diameter of a tree trunk, the amount of kids in each grade level, the amount of boys and girls, looking at specifically the numbers. All right, so that's your quantitative data. So any questions on that? Pretty straightforward. All right. All right, so then we have eye color, gender, location, satisfaction rankings are all examples of qualitative stuff. So this rankings just mean like first, second, third, fourth, that ordinal. These are all going to be qualitative. Variables. Temperature, which is a number, age, which is a number, number of pets someone owns in a family, which is a number, the weights of somebody, or maybe the weights you're lifting, are all examples of quantitative variables. Quantitative variables are numerical and can be ranked or ordered. Quantitative variables can be classified into two groups. So now we have our two main things. We have qualitative, quantitative, and then within those, there are other groups that we saw earlier. So quantitative can be broken down into either discrete and continuous. Discrete is like actual numbers, like 1, 2, 3, 4, 5, 6, whatever the answers or numbers might be. Continuous are more like decimals. So if you like to think of it, discrete's like whole numbers. Add some notes in here. So these are like your whole numbers. And continuous, these are going to be like decimals. Like for instance, if you're dealing with the height of somebody, that's going to be continuous data because they could be 5 foot 4 inches, then 5 feet 3 inches, or maybe you're talking about centimeters of a flower. So maybe it's 2.54 centimeters, 5 centimeters, like all these different decimals. So continuous can have whole numbers in it, but it'll also be mixed in there with a lot of decimals and stuff like that. But like discrete would be more like ages, like you're 17, you're 16, you're 14, like those, you're not 14.8. Like we don't say that on the thing. We might tell people I'm 14 and a half. No, you're 17 because you haven't quite turned 18 yet. All right, so then so and that basically is what they're saying here in their own words. So I'll read it for you so you have it for your notes. But discretes, quantitative variables assume values that can be counted, such as number of people in a household, the number of eggs needed for a recipe, or the number of chairs at a table, right? We don't have pieces of these things. These are whole things, so no decimals are needed. Any questions on discrete? All right, so let's talk about continuous. All right, so in this one, this is our continuous quantitative data. Quantitative variables can be assumed an infinite number of values in an interval between any two specific values, such as temperature, amount of baking soda needed. So temperature could be, 49.5 Fahrenheit or 49.8 Fahrenheit or whatever you're looking at. Amount of baking soda needed for a recipe. You could have 1/3 cups, which is a decimal, or you could have, 1/4 cup, which is a decimal. Weights of a book. So again, a weight of a book could be 2.5 pounds, or it could be 7.8 pounds. It's not just whole numbers. There could be some decimals in there. Quantitative variables are obtained by measuring and can include fractions and decimals, as we just said earlier. So that's good things to highlight there. Continuous variables may be recorded as the nearest inch, nearest ounce, or nearest unit of measurement. So values could take on any value in an interval from half a unit below the recorded value up to, but not including, half of a unit above a recorded value. So if this was continuous data, I could say something is 4 feet. Get this all cleared up again. So I could say it's 4 feet, but we know if we're measuring something, it can be a decimal. So it could read out as 3.5 to 4.5, but not including 4.5. So you'll see here that the 4.5 inequality does not have the equal to. So it goes from 3.5 to 4.5, but not including the 4.5. So if I say something is 4 feet and I'm just trying to, we do this to try to organize our information. Maybe when you want to get interval data for all the people that is between 3.5 and 4.5 feet. Obviously, we're going to be at elementary school because I don't know if we have any students that small. But then we'd have another section for 4.5 to 5.5 feet, and we'll call that 5. And then we'll have like 5.5 to 6.5, and we'll call that 6. It just makes organizing your data in an Excel sheet a lot easier because we can say there is 32 people at 6 feet, and then we know with our data that's just between 4.5 to 5, or sorry, 5.5 to 6.5 feet tall. Does that make sense? It just helps organize your information a lot easier. So you don't have like 1,000 decimals. Like we have one kid that's 5.5 feet. We have another kid that's 5 and 6 feet, and then it just kind of keeps going, which can be a little confusing when your data. So a value recorded at 8.3 may be any value basically from 8. We did this earlier, 8.25 up to, but not including 8.35. So you remember doing that pre-lesson when we were trying to find the interval range? This is where that then comes into play. Questions on that? All right, let's move into objective 4. All right, so in objective 4, we're going to be identifying level of measurements for each variable. So it says qualitative and quantitative variables can be classified or categorized using measurement scales. And the 4 common types of scales for classifying variables are as follows. And we saw this last week as well. And I'm trying to say this right, but it's nominal, right? Nominal. Look at me learning. Ordinal. And since we already kind of know this, I'm going to kind of see if I can quiz you real quick. Nominal basically means what? Named. Ordinal means what? The order of something, like first, second, third. And then we have interval. Very good. Interval has a absolute 0. So interval would be like height of somebody, right? We don't have someone that's below 0 feet. But ratio does what? Goes below. So a good ratio one would be like temperature, where the ratio could be, or do it. I think I might have it flipped the more I say it out loud. Hold on. Hopefully not. Hold on. Yeah, okay. I do have it backwards. Interval includes the 0, ratio does not. So I like what Malachi or Charlie just said. Ratio has the word a letter 0 in it. So it means 0 is defined. I'm gonna remember that way now because so interval doesn't have an absolute 0. So interval will be like temperature, where it can be from like -10 degrees to 20 degrees or something, where 0 is not absolute. Ratio would be like height. So like we don't have negative height. What's another good ratio version? Age could be a ratio because it can't be negative years old. So there you go. So those have absolute zeros. Batteries, I would say that would be a ratio because at 0%, it's no longer working. We don't have negative percentage. So that would be a good one. Let's see what else we got. All right, so the lowest level of measurement is nominal. It says classifying qualities, qualitative variables in non-overlapping categories that can be ordered or ranked. This will be ordered or ranked. So again, nominal data could just be, all right, all the people that are blonde headed, all the people that are black headed, all the people that are brown headed, all the people that are gray headed or whatever. I can put all of these into a group and order in that sense. A rank could be a good one. I could say all the 9th graders, all the 10th graders, all the 11th graders in a sense of rank. So some examples to go with that. So these are labels for which there is no meaningful order or rank. So in this case, zip codes. So we talked about how qualitative data is typically not numbers. Zip codes is actually a qualitative stats there because it just gives a location. It doesn't actually have a value meaning. Like our zip code is 77331, but then Cleveland is 77328. It just gives a location, but not an actual value of something. So zip code would be actually a nomial situation. Address, obviously, it's a you live off Butch Arthur or something like that. That's an address. Social Security, again, that's basically like a name plate attached to us with a number. So again, those numbers don't have specific things. I've always thought that maybe Social Security number started at 1 and then we went up, but I don't think that anymore because we would have gotten bigger Social Security numbers now. Which I wonder if like someone dies, do we get to reuse that Social Security? But I have no idea. Yeah. Gender could be another one when it's male and female. Ethnicity, again, that's just your race. Company and corporation name is another one. ISBN number, that's a basically another name for a book. So instead of putting the name, I can type in this number so that doesn't actually have a value. Tracking numbers, same concept. If I'm trying to track a package or something, that number is just attached to my package. It has no meaningful value of it or rank in a sense. And then television channel 2 just takes me to a, what is that, NBC, and channel 10 takes me to Fox, but yeah, I don't even know cable anymore, so I don't even know what dishes numbers are. So, or DirecTV, but you have like numbers to a channel that attaches to something, has no meaningful order or rank in it. Any questions on examples of nominal? These are all nominal examples. They're names, even though there's numbers in here, these are numbers that are attached as a name. So instead of saying Citizen County, I can just say 77331. Both of them mean the same thing. Instead of having the ISBN number, I can say statistics book or whatever, and then those are the same concept. Tracking numbers will be your package that's coming, right? So all of these are attached basically to another name. We just use numbers to easily put into the computers and stuff like that. Any questions on that? Okay. The second level of measurement is ordinal. So that's just classifying qualitative variables. Where's my pen? So this is just classifying qualitative variables into categories that can be put in order. Or assigned rankings. This is what ordinal. So first, second, third, president, vice president, things like that. Questions on the way this wrote? So ordinal again is just the order that I can put something in. So examples, these can be put in a natural order, but precise differences between values cannot be measured. So satisfaction rankings, so superior, average, poor, needs improvement, unsatisfactory, all those letters you get on your report card, the SEs, NUs, this will be a great example of an ordinal situation because you qualify in certain situations. Football team rankings, Cold Springs is first in the district, and then everyone else falls below us. So like things like that. Some clothing sizes, so like extra small, small, medium, large, extra large, 2X, 3X, 4X, or youth, small, youth, medium, all those different rankings of clothes. Pain level. If you ever go to a doctor, like what's your pain level, 0 to 10, you give like, all right, I'm at an 8 or I'm at a 2, but your arm is hanging off because you don't feel it no more. So it's like the pain's not there because I lost it, but I could use another arm, things like that. Ranking preference on vacation sites. Again, if you're ranking something, that's going to be ordinal. Like I would like to go to Hawaii, that's 10. But to go to Livingston, that's like 1 for me. That's not my favorite vacationing spot. So things like that. Any questions on that? All right. So let's see. Make sure I don't miss anything. So again, levels or rankings by one person may not have the same meaning for another person who selects the same ranking. So the rankings might change between people. It all depends. But then we could use that to figure out, what's everyone's highest top priority ranking, and then use that as data as well. All right, the third level is interval. This is one we won't get wrong because interval does not have an absolute 0, right? So this is the first level that classifies quantitative data. So again, qualitative is nominal and ordinal, and then quantitative will be interval and ratio, if you want to kind of make a little chart there. So interval is the first level that classifies quantitative. Variables. These can be ranked or ordered, have precise differences between units of measurement, but have no meaningful 0. And if we just read our notes, we would go on to that. That is the placement of 0 on the measuring scale is arbitrary. It can mean different things. All right. So like for instance, with temperature, like 0 degrees Fahrenheit does not mean the absence of temperature. It just means 0, right? All right. So in this example, so let me pull it all the way out. So this example says these values have a natural order, differences have meaning, but 0 is not meaningful. So like Fahrenheit temperature, it's 98 degrees is hotter than 43, but 0 doesn't mean no heat. That just means it's really cold for us here in Texas. Celsius temperature, that's well, I think that's different. No, my bad. That's Kelvin I'm thinking of. Celsius, same concept. 98's hotter than 43, but 0 doesn't not mean absence of temperature. But Kelvin, 0 degrees does actually represent the absence of temperature. So Kelvin, if you think of Kelvin, that's actually going to be more of an example of a ratio. Kelvin does go to 0 and that's what we call absolute 0, which is, I guess, I don't think we've ever seen it, but it's like when something freezes in time and time stops. Yeah, so that's their theory on absolute 0 Kelvin. Calendar years, we don't. I mean, we have 2000 after AD, and then you have 0, and then you have 1 BC and 2. Like the 0 is not absolute in our years. Time of day, but not length of time. So time of day, we when we get to midnight, it's we have time before that and time after that. Like it's not 0, it's the absence of the day. Scales such as the standardized scale of a political orientation that are constructed to have equal intervals. Yeah, I don't know that one. Standardized scale of political orientation. Yeah. I got any thoughts on that one? I don't either. My only example I can think of is maybe the thing about percentages and stuff. So we can't have less than 0% people that would go for, Donald Trump or Kamala Harris or whatever the party's running for. So that's what I'm going to go with is can't have negative people going against people. All right, and then we get into the last one. The fourth and highest level of measurement is ratio, which has the same characteristics as interval and has they say true zero. This would be a true zero, which is basically just a zero with meaning. So weights can be ordered ascending or descending, but we can't have negative weights. So again, it goes from 200 to 90 pounds, 110, but there's no absence of weight, or zero would represent the absence of weight. So any questions on interval, or not interval, ratio? Again, since it has the O in it, we know it has an absolute zero. So here's some more examples for that. These values can be ranked or ordered, have precise differences between values, and have a true zero. Ratios make sense. For instance, 12 miles is twice as far as 6 miles. So distance, again, we don't have negative distance. Volume, you don't have negative volume. Number of books in a library, we don't have negative books. We either have books or we don't have books. GPA, you can't make below a 0.00. I mean, you can surely try. We have some students that are, but you can't go that far. Years of work experience, you either have 0 years of experience or you have more than that. We don't have negative years. It's not like you suck at your job so bad they take years away from you, going, yeah, you need to start over. Uh, household size, you either have no one living there or you have a family of 1, 2, or 3 or more. Weight of recyclables discarded each week. Again, anything that talks about weights, you can't have negative weights, right? 0 truly does mean the absence of weights. All right, so here is our example, and I think this is where we will end it today. But classifies each of the following variables as either qualitative or quantitative. I think that's the easier part. And then determine the level of measurement. Is it nominal or ordinal? Remember, nominal ordinal goes to the qualitative side, and then interval or ratio, which goes to our quantitative side. Yes, sir. These are your notes. You can do whatever you like. On my test, though, I would expect you to write out the entire word, though. Right? So let's do these together to make sure we understand it, and then y'all can jump right back into the homework. So I'll try not to look at the key so I can work this with you. Let's do a different color. Pink looks good today. All right. Eye color, qualitative or quantitative? Qualitative. It's not a number, so instantly falls into the qualitative. Qualitative. I won't take off for spelling. And then would it be nominal or ordinal? Nominal. There's no rank of eye colors. We don't say that green eyes are better than everybody else. I like to agree, even though mine are brown. All right, we got the first one right. All right, next one. Number of years employed by a company. Would that be qualitative or quantitative? I'm going to go with quantitative. It specifically has a number and it has a purpose. I either have 10 years of education experience or you have 1 year of education. It has a ranking order. So this would be quantitative. And then if it's quantitative, it's either going to be interval or it's going to be a ratio. So what would this be? Ratio. When you're trying to figure this out, just ask yourselves, is there an absolute zero? And in this case, I do have 0 of experience, but I cannot have negative experience. Right? I'm pretty sure we got that one right. We did. Ranking of a tennis player. Qualitative. It deals with numbers, as in like first, second, third, but the numbers don't have a meaning. So this would be qualitative. And if I'm ranking a tennis player, what is my type of measurement, huh? Ordinal. Very good. Both as in what? We'll still have a ranking. Yeah. So it could be first, second, third, fourth, or it could be that, it's Charlie's number 1 and so on and so on. All right. So that's all I got. We'll recap that as a warm up for tomorrow. Get into Alex. Make sure you go ahead and do that knowledge check. It's going to force you to do it before you can actually get into the program anyways. And what it does is just give you some things to help you work on things. And then you should be able to find your homework. So that's your challenge. Knowledge check, and then make sure you can find the homework. You don't have to start it, but at least find it so that you have questions tomorrow. Y'all enjoy the rest of the day.